Okay, all right. Picking up where we left off, good people. I hope all is well. Now we are just got through looking at functions. So now we're looking at graphing functions. Graphing functions. Now some of these functions will be similar to graphs that you've worked with before, as with these first two. We have f of negative 2x and g of x of negative 2x minus 4. Remember, that's similar to saying y is equal to negative 2x. In this case, we'll say negative 2x plus 0. And then our second one, y is equal to, and let's change the color on that one. Y is equal to negative 2x minus 4. All right, so we are going to go ahead and use the slope-intercept form. Slope-intercept form, remember, that's your y equals mx plus b, where b represents the y-intercept and m represents the slope. So if I have y equals negative 2x, I know that my y-intercept for that is 0. And then my slope, remember we use rise over run. So since I have a negative 2 over an understood 1, that means that from my y-intercept, I will go down 2 places and to the right 1 place. 1, 2, 1. Now when you're graphing in MyMathLab, you only have to plot 2 points using the line tool. I'm going to go ahead and plot one more. 1, 2, 1. And then we would draw a line through those points. Like so. All right. Now let's graph the g function. So let's graph the g function. I'm going to graph it in blue. The g function was g of x equals negative 2x minus 4. So here I have my y-intercept as negative 4 for that one. So come down here to negative 4. And then my slope was the same as the other equation, negative 2 over 1. Now, if you remember back that when you have the same slope but different y-intercepts, those lines are parallel. So same slope, I will go down 2 over 1, down 2 over 1. And you see that those lines will never intersect, but we also see that the only difference between the f of x graph and the g of x graph is that that thing shifted down 4 places. So it shifted down vertically down 4 places. So I'll make my line here. And it's not perfect, but it's close. And this thing, we can see that the difference is that the G graph shifted down 4 places. And you can see that gap in between there. Everything else is the same, but the G function shifted down 4 places. So the difference here, the graph of the G is the graph of F shifted down 4 units, D. So when you're doing these, you will graph each one of them using the line tool to graph 2 different graphs. And then you'll also look at them, compare them, and see how is the second one different from the first one, how it compares. Okay? Alrighty. So let's look at one more of these. Now again, we know that the absolute value creates a V-shaped graph. And since we don't have anything being added or subtracted inside the absolute value with x, I know that my vertex for my graphs will be 0, 0. Or the vertex for the first graph anyway will be 0, 0, since I have the absolute value of x. So if I make an XY table, if I plug in, let's say 0 for x, then I will get out 0 for y. If I plug in negative 1 for x, then I'll get out positive 1 for y. Or if I plug in 1 for x, I will get out positive 1 for y, because the absolute value of negative 1 is 1, the absolute value of 0 is 0, the absolute value of 1 is 1. So I know I'll have something like that for my f of x graph. Now my g of x graph, you see we have this -4 here. That's a vertical shift. That's going to help me to find my y-intercept. That's a vertical shift. So that's the only thing that changed. So with that being the only thing that changed is that -4 outside of the absolute value of x, I know that this, my original graph, is shifting down 4 places. So again, this is g of x. So if I do an xy table here, then I'm going to start with -4 because I know this thing shifted down 4 places because of the -4 outside of the absolute value symbol. So -4, the absolute value of -4 is 4, and 4 minus 4 is 0. And then let's do -3 here. The absolute value of -3 is 3, and 3 minus 4 is -1. So -3, -1. And then 3, the absolute value of 3 is 3, and 3 minus 4 is -1. So again, you have that symmetry there. So you can see that the g function graph is the same as the f function graph, except that it's shifted down vertically 4 places. Okay, so this one is similar, number 9. So you create your tables, and it says which of the following shows, and then you see which one of those graphs show the 2 graphs, and they give you x values to plug in here. So remember, if you have a number outside of that function of x there, then like that -2, then that's a downward shift for that particular graph. Okay, now we identify functions by looking at sets of pairs, ordered pairs, and we said that each value of our domain can be paired with only one element of the range for that set of ordered pairs to be a function. Well, it's the same thing here, but we get to use a cool little trick called the vertical line test to test graphs to see if they're functions. And basically what that says is that if I can draw a vertical line anywhere through that graph and that vertical line touches more than one point on that graph, then whatever figure we have, that is not a function. So if I draw a vertical line here, then I see that my vertical line will touch more than one place, here and here, more than one point on that graph, so I can say that y is not a function of x. So if I can draw a vertical line anywhere through the graph and it touches more than one point, then y is not a function of x, because what that tells me, and let's just say that this is x, that this is -4 over here on the x-axis. Let's say it's that -4 is paired with whatever y value this is and whatever y value that is, which would make it not be a function. So if I look at this one, it says use a vertical line test. Well, it doesn't matter where I try to draw a vertical line through that graph, it will only touch one point at any given time. I cannot draw a vertical line anywhere through that graph and make it touch more than one point of that parabola. So here, yes, y is a function. Okay, number 12 says use the graph of f to find the value of f of 5. Well, this is saying in words, this is saying what what is the value of x? What is x when y is, I'm sorry, go back again. What is the value of y when x equals 5? What is the value of y when x equals 5? That's the question that you're asking. What is y when x equals 5? So if I come over here on my graph and go down my number line, my horizontal number line, my x-axis, until I get to 5, which is right here, then I want to know what is the value of y where x equals 5. Well, I will go right down here, and I see that the value of y when x equals 5 is -3. What is the value of y when x equals 5? So that's the point of 5. And I went over one too many, didn't I? I'm sorry about that. Let's try that again. 1, 2, 3, 4, 5 right here. So when x is 5 right here, right there, then y is 0. So we looked at f of 6 first. When x is 6, then y is equal to -3. What about when x is 9? So we go over to 9. When x is 9, y equals 0. What about -4? So f of -4, we come over here to -4. At -4, the value of y is 3. So that's how that works. Whatever's in parentheses, you go to that x value and you go or you figure out what is the y coordinate that goes with that x value when x is 5 in this case, or 6 or 9 or -4. So here it says for what value of x is g of x equal to 5. Now it's saying when y is 5, what is x? So you find 5 on the y-axis, which is here, and then you go over until you get to that x point, and we see that x is -5. So when y is equal to 5, what is the value of x? So that's the difference in between those two. Okay, this one says use the graph to determine the function's domain, range, intercepts, any of the values below. So domain runs from left to right, and it may do you some good to, if you have one like this, to kind of draw a little imaginary box around it. Because when you look at the domain of the graph, you're looking at how far does that graph run from left to right along the x-axis. So with regards to the x-axis from left to right, we see that my box goes from -4 all the way over to -3. And it says type this thing in interval notation. So since I have these endings that are closed, I would use brackets for interval notation. So it goes from -4 all the way over to -3. So since I have the closed circles there, that means I'm including those numbers. Now it says, what is the range? Well, the range would go from bottom to top. So again, if I look at my box, I see that my box goes from -1 up to +6. And again, I have those closed endings. So my range is from -1 all the way up to +6. Okay, so use that kind. If you can draw a box around your figure, that'll help you determine your domain and range. Now it says, what is my x-intercept? Well, my x-intercept again is where my line crosses my x-axis, and you see if you run along the x-axis that it crosses at -3, which would be the point of -3, 0. But it didn't ask for an ordered pair. It just says, what does x equal? So x equals -3. What about the y-intercept? The y-intercept is where the graph crosses the y-axis. So we go up on the y-axis, look at the y-axis, and we see right here that the graph crosses the y-axis where y equals 3. So yes, we do have a y where y equals 3. And then last but not least, it says, what is f of -3? So remember, if it's in the parentheses, it's asking when x is 3, what is the value of y? So when x is 3, so if I go to 3 on my x-axis here, I get right here, and I see that the value of y is that x-intercept. So the value of y is 0. What if it asks what is f of -2? So it's saying if x equals -2, what is the value of y? So if I go to -2 on my x-axis, I would have to go up. And I see here that y is equal to 1. So again, that's how you look at those graphs when you're being asked for the value of the function. All right, good people. I hope you found this video to be helpful. I think that should get you there. Well, let's look at number 17 before we go. And 17 says we have a company that manufactures bicycles and has a fixed cost of $90,000. It costs $100 to produce each bicycle. The total cost for the company is the sum of its fixed cost. Sum means addition. So we're adding the fixed cost of $90,000, and let's write this over here. Sum of the fixed cost plus the variable cost. Write the total cost C as a function of the number of bicycles produced X. So the fixed cost is $90,000, and then it's going to cost us $100 for each bicycle that we make. So that will give us C of X equals 90,000 plus 100 times X. And then it says find and interpret C of 90. So if I want to find and interpret C of 90, then I need to replace X with what? That's correct, 90. So multiply. So I have 90,000 times or plus 9,000. And 90,000 plus 9,000 would be $99,000. So we're asked to interpret this thing. Well, C of 90 equals 99,000. Therefore, it costs 99,000 to produce 90 bicycles. It costs $99,000 to produce 90 bicycles. Okay, guys, no, that's it. I hope you found this video to be helpful, good people. Ladies and gents, have a great day, and I will see you on the next one.